Hello, this is Mr. Collier, and today we're doing integration with U Substitution. Okay, so let's do this one here first. Now this is a linear factor in here, so we can treat it just like an x squared. And recall the integral of x squared is x to the power 6 over 6. So we can do that here, and we have x minus 5 to the power of 6 over 6 plus c is the answer. Okay, so what we did there is we just considered this to be one whole function to the power of 5. So sometimes we do what's called a U substitution. So we let U equals, and this is particularly useful for a more complicated expression, and then dx, or du equals the derivative of that is just dx. So if you substitute the values in, we have integral of u to the power of 5 du, and then we just substitute, or we integrate using u instead of x. Not really necessary for this one, but for a more complicated one it's very handy. Okay, so like for this one here, we can let u be a function of x. So usually you want the more complicated thing to an exponent or with a surd under it. So we're going to take this complicated expression here and turn it into u. Okay, and then du equals 2x dx. Now we don't have a 2x dx, we have an x dx. So we could say half du equals x dx. That means in the equation, or the integral, I can replace x dx with half du. So this integral becomes half the integral du, that's from the x dx. And this one here becomes just u to the power of 4. Okay, now when we integrate, we increase the exponent by 1. And then I divide by 5, or multiply by 1/5. And then I've got a half still here, plus c of course. So that's 1 out of 10 times u to the power of 5. Now we can substitute back in our x value, so it's this. Okay, so that's the final answer. You can check, you can, oops, I forgot 5. You can check, you can differentiate this, and you do get that one there. Okay, so next, let's try a couple other examples. So here you're going to let u equal the thing under the radical sign. Okay, so then du equals 3x squared dx, so 1/3 du equals x squared dx. So I can replace the x squared dx with 1/3 du. And the u is just u to the power, or the square root of u, which is u to the power of half. So we increase the exponent by 1. That means we're going to have to multiply by 2/3 plus c. And then substitute, always substitute in what the value of u is. It's x cubed plus 5 to the power of 3 over 2 plus c. Here we're going to let u equal that, so let u equal x squared plus 3, du equals 2x dx. So again, you're going to have a half again. We can write this as half times the integral of cosine u du. Integral of cosine is sine, so we have sine u, and I'll just substitute in the u right now, so it's that. Plus c is the final answer. Here, notice the derivative of x cubed is x squared, so this is going to be your u. Let u equal x cubed minus 3. du equals 2x squared, so dx. So half du equals x squared dx. So we're going to have half times the integral of e to the u du. And integrating e to the u is easy, that's just e to the u. So we're going to have half e to the u plus c, and then u is just x cubed minus 3. Now here, notice if the derivative of ln x is 1 over x, so you can let u equal ln x, and du equals 1 over x dx. So this is the same as the integral of sine u du, right? This whole thing, this 1 over x dx all becomes du. So the integral of that is negative cosine u du, or negative cosine u plus c. So that's negative cosine ln x plus c is your final answer there.